In this video, we will discuss decorator. Well, it is a concept that allows us to modify the output of a function without modifying its code. Well, it will be very clear once we have gone through this entire sheet as to what exactly is meant by this. You want to modify the output of a function, but you don't want to touch the code. Now, how it can be achieved? I mean, when and why to use decorator? Basically, there could be a scenario that you cannot touch the function. You cannot modify the function. Okay. Maybe this particular function has got some common code which is used by many other functions. And hence, maybe modifying it may not be desirable. That is the basic idea behind it. To build a decorator, we have some building blocks. There are some basic requirements we have to understand. To get a better understanding of how decorators work, we must understand a few concepts first. These concepts are building blocks for creating a decorator. So what are these building blocks? Number one, a function, like everything else in Python, is an object. It can be assigned to a variable because it is an object. After assigning a function to a variable, we can use the variable to call the function. What exactly is meant over here? Let us see with this example. See, I have defined a function over here, func print hello. This is a very small, simple function. It is just printing hello. What I'm doing over here, I am invoking this function by writing like this, func followed by parenthesis. Now, when I write this, the function executes, right? So let me comment this here at this point in time. Let me run this. Okay, hello. Now, next what I'm doing, okay, that hello has printed very good, but I can also store in a variable this function. Now, what does it mean? When I am storing this function in a variable means I can write like this, a followed by parenthesis, it is going to invoke the function. So whether you write function name followed by parenthesis or you simply write function without followed by parenthesis and assign it to a variable and in turn write a followed by parenthesis, it is going to do the same thing. Now when I execute this entire thing, I will get hello twice. One hello will come through this syntax, the second will hello will come from this syntax. Okay, so two hello I have generated. So this is what is being said over here, that it can be assigned to a variable because it is an object. Function is an object. Function, basically this function is an object. By this, by writing like this, I am just assigning this particular object to a variable so that a, in fact, even a becomes an object. So basically it is referring to the same function. So if I write a parenthesis, it is going to do the same task. So that was one of the requirements. Let us move on to the second one. Second says a function can be nested within another function. The nested function is called inner function and the enclosing function is called outer function. The inner function can be invoked from within the outer function. What it says, see this function I have defined. Okay, the function name is func1. Here I am printing hi, I am func1. This is outer function. Why it is outer function? Because there is another function which is defined inside it. The name of the function is func2 and this is called inner function. See, func2 is inner function with respect to func1 which is outer function, and function1 is outer function with respect to this func2, which is inner function. So that is what is inner and outer means. Now in inner function, I'm writing print I am func2. So this is a function. It has another function which is called nested function. Here I am printing func2, and what I can do is, see, inside this function, whatever I have written, I can execute all the lines. Since this particular function is defined, this function 2 is defined under function 1, in within this particular function, I can invoke function 2 as well. So what will be the output when I invoke this function 1? When I invoke the function 1, first will be, it will give me an output, hi, I am func1. Next, what it is doing is it is defining this function, just defining. It is followed by invocation of the same defined function. Now when I write, this particular function is getting activated, executed. So what happens is function 1 is printing hi I am function 1 from this line, and then this is definition, and when I invoke this, it gets activated. So this output is coming hi I am function 2. This is what is happening when I am invoking function 1. So we can see here, see, hi I am function 1, hi I am function 2. Right? So this is what the nested function is called inner function, and enclosing function is called outer function. The inner function can be invoked from within the outer function. So this inner function is being invoked from within outer function. This is outer function. So this function is getting invoked from here. Right? Simple. So clear. So that is what it is. Let us see. There is a point to be noted over here. We must note that func2 cannot be accessed, invoked, activated, or executed from outside the outer function. Doing so will raise name error exception. Let us try. So what it is saying is, you have written function 1. The function 1 is getting executed, and inside function 1 you can invoke function 2, but you cannot write this outside. Now what is outside means? Outside the scope of function 1 you cannot write. This is the entire, this is the area, this is the area of function 1. Outside this you cannot write function 2, because once this function is exiting, everything is erased. There will nothing be there in memory. So how come you can really invoke that is inside that? So you cannot access that. And that is precisely why you will get error. Just see, the error is what? It says name func2 is not defined. Obviously, right? This function is cannot be seen outside. It can be seen only inside because it is existing inside function 1. So that is how it has to be executed. Okay. I hope it is clear. Now let us see this. 3. A nested inner function can be returned from the enclosing outer function. See, I have this function, func1. Clear? This is outer function. It has got another function, func2. It is inner function. So, since inner function is defined within function 1, I can write this statement. I can say return func2. Basically, from function 1, I am returning the object func2, or I can say I am returning this function. So, anything that you return from any function, you should store in some variable, right? So, when I am invoking over here func1, since it is returning func2, I'm storing this func2 in x. So at this point in time, basically x is holding func2. And how I can execute func2? I can execute func2 like this. This is how I'm executing, right? I executed over here func2. So that is the way I could have done inside this particular function. Now outside, I will write x followed by parenthesis. So when I store this, and later in the next line I am writing x parenthesis, basically I am executing func2. So just see that output. So now what is happening? When I have invoked function 1, it generated this output, hi, I am function 1. And when I invoked this outside, it gave me this output, hi, I am function 2. So this is what is said, is conveyed by this particular point, that a nested inner function, this particular function can be written from the enclosing function. From the enclosing function means what? This enclosing function, which is outer function. It can be returned from enclosing function means this is the scope of the function. From there you can return. Having written that, you can execute this outside. Okay, we discussed, right, that I cannot write function to outside, but there is a way of sending it outside and invoking it. This is how from outside you can invoke function to. If you write here, right, if you write here outside, if I write somewhere here func2, it is going to give me error. Okay, so that is a work around that. Invoke this, return this, and then store in a variable, and then write variable followed by parenthesis that is going to invoke function 2. That is the way you go about it. So this is another point that should be kept in mind. All these things are going to get used when we are going to write our decorator, right? So we have come this far. Let us talk about point number 4. A function can be passed to another function as an argument. What is this? It says that, look, I have function f1. I'm saying print, hi, I am f1. And I'm invoking f. What is this f? I have not defined. Look, what is happening is this particular function 1 accepts an argument, a function argument. I mean, so what I will do is, since I have written f followed by parenthesis, then this has to be a function that should be sent when I am invoking func. So when we write, so I have defined f2, print hi I am f2. That is another function. So you have two functions. This is one function and this is one function. The difference between this function and this function is that this function is not accepting any argument, but this function is accepting an argument, and that argument has to be a function because I am writing f parenthesis, which means I'm invoking that. So what I will do is, when I'm invoking f1, I am passing another function. What? f2 I am passing. Don't, we will not write parenthesis, only f2. And then f2 will get copied over here as f, and then I will invoke f as this. So when I invoke this, I will get this output. Hi, I am f1. Hi, I am f2. So let us see the sequence. Here what is happening? f1 is being invoked with an argument. Okay, so here the argument is copied onto f. Right? So since what is this argument? It is basically a function, right? So it is going there. And here I am simply printing hi, I am f1, and then I am saying f parenthesis. When I write f parenthesis, the function will get invoked. Which function? Basically f2. And what is happening inside f2? Print hi, I am f2. And that is precisely what has happened over here. So you can also pass function as an argument. Okay. Now, we have already seen 4 points, right? Number 1 says that I can assign a function to a variable. This is, I have assigned a function to a variable. Good. Point number 2, what it says, a function can be nested within another function. Well, I have done this nested function, and the nested function is called inner. Okay, that is called fine. The inner function can be invoked from within. So what is saying that I can have a nested function? Yes, it is nested function, and this nested function can be invoked from the outer function. So this is inner function, this is outer function. From within outer function I can invoke. So I have seen that. Good. A nested inner function can be written from the enclosing order function. So what I'm doing over here is I'm not invoking function 2. I'm returning function 2. So when I do that, when I invoke function 1, the end result is what? Return function 2. So it is getting copied into x is getting, so that is point number 3. Point number 4 is that a function a function can accept another function as an argument. So this function is being sent to this function as an argument. And when I am executing this, this is one line of that function one. Another line is invoking the function which has been passed over here as an argument. Okay. Here I can write any name. I can even write the same name. F2 here, and here I can write F2. Name doesn't matter. I can write F2, nothing will happen. So F2 is getting copied as F2. See, output is not going to be different. Okay, I'm writing different name only to distinguish between this and that. But otherwise, output will be same. It is not making any difference. Okay. Now, how to create a Python decorator? Having understood those points, those building blocks, now we have to get to writing a decorator. Okay, so in decorator, what happens? Create an order function that takes a function as an argument. I will write. So we have already seen how I can write a function which takes another function as an argument. We will do that. Define an inner function that wraps around the decorated function. This is a little difficult to understand. This will be clear only with an example. But let me do first. What I'm doing, I am defining a function outer, and this func argument arg is nothing but it is basically an argument. What is your argument here? Argument is equal to func arg. Some function will be passed which will be known within this function with the name func underscore arg. Okay, good. Now this is the inner function. I'm coming to that, what I'm going to do. Then I am invoking this inner function. I can always invoke nested function from within the scope of outer function. Correct? I can do that. So now what is happening? Just see. I have a function. I have a function. This def func print hello, how are you? This is the function I have. Okay. Now what I'm doing is I am passing this function when I am invoking outer function. So look at the sequence of the thing. When I say outer function, outer will get invoked. This function will get copied here. So what is getting copied? Let me write here like this. Sorry. Here I say equal to, basically function, this particular function is getting copied into func arg. Okay. Now, def inner. What def inner is doing? Def inner is, the inner function is invoking this func arg. What it will do? It will print hello, how are you whenever it gets invoked. And then beneath that, below that, I have written print underscore 18 times. Right? Now, I am invoking now inner here. So what happens is when I say outer function, what is happening is this particular function is getting invoked. This particular function is getting defined. And when I am saying invoke inner, what will happen? Inner will first activate this function, the function which was passed as an argument. So when it is getting invoked, it will print hello, how are you? And then print underscore 18 times. So what it will do? Just beneath hello, how are you? It is going to print that's dash 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 18 times. Just see, is it happening like that? Yes, it is happening. Outer function, hello, how are you? That. This is what is happening. Now what we will do is, as we have learned that we will not invoke this here, okay? We will simply pass. So if I am passing, I will have to have something to receive. So here it is. I would like you to look at this particular cell now. Okay, that is over. Look at this particular cell. Okay. Uh, Let me write this so that your concentration is only on this particular cell. So def I am doing everything exactly the way I did here. The only difference, just see here, it was getting invoked from inside outer. Now, from inside outer, I am not invoking, I am passing inner. So what is happening is when I am passing this particular, the end result of this will be what? X will be equal to inner. See here, X is equal to inner. Then when I write X parenthesis, well, whether you write X like this or you write like this, it is same, right? Inside, if you write inner, whatever output you are going to get, outside when I write X parenthesis, I'm going to get the same output. Done. So hello, how are you? So this and this is same. Let me repeat. Here I am invoking here. Here I am invoking inner function outside. We have learned that inner function cannot be invoked outside. So that is precisely, that is the reason I am having this workaround. I am sending this function to the calling function, right? This is where it is getting called, and then I am copying into X, and here I am invoking the same thing is happening. These are two different ways of invoking inner function, remember. But in decorator, we will be using this. This is what we are going to use. We are not going to use this. Okay. So one thing that we have achieved over here is my original function is giving only output as hello, how are you? Without touching this function, I have modified the output. How? My modified output is underscore as well. This is the basic concept of your decorator. But the problem over here is you have to write two additional lines, right? Outer function, you assign into a variable, again you invoke that variable, and then you are going to get this output. There is a way of dealing with in a more elegant manner. Let us see what is that elegant manner I am talking about. So let me bring it up. Here I go. Okay. What is syntactic sugar? Let us understand what is syntactic sugar. In computer science, syntactic sugar is syntax within a programming language that is designed to make things easier to read or express. See, when you write like this, it doesn't look that, you are going to have function giving me something very different than what it normally gives. It doesn't give because I'm writing outer function, assigning it to X, executing. Now see what happens. What I will do is the function, the way it is defined. Now what I will do is I will define like this. I will define this function, and on top of this function, I will write at outer. What is this outer? This outer, this particular function within which I have a nested function, and this nested function, this inner function is invoking my original function and also doing additional thing to make things look as if my original function without getting modified is giving me modified output. So you have to write outer at the outer and define this. And now what happens is I am only invoking function. What I'm doing? I'm only invoking function. This internally system is doing all the magic that these two lines are doing there, right? So what I can do is wait. Yeah, I'm defining this. So let me bring this as well here. I will bring this here. Okay. And right now here. Correct. I will copy. Just see what is happening. I will delete that. See what has happened now? I'm putting everything together. Now what has happened is this particular function, this is the function. Hello, how are you? On top of I have written at outer, and I am now invoking just the function, and it will look as if that, something modified thing is happening. It's actually happening, but this is what you are writing, right? This is called syntactical sugar. It is letting us not write these two lines, which is little complex. So right here, see, hello, how are you? This is called decorator in complete sense. This is what a decorator is all about. Decorator means what? Let us go back to its definition. It is a concept that allows us to modify the output of a function without modifying its code. When and why to use decorator? Like, we use a decorator when we need to change the behavior of a function without modifying the function itself. A function may have a common code that is used in many other functions, and hence modifying it may not be desirable. And we have also seen building blocks of that. So this is all about the decorator. And this I have already consolidated, so there is no need to do this. Let me remove this. I have done that. Okay, the same thing I have done here. So let me remove here. Otherwise, let me eliminate that. Let us consolidate. I wrote, and so basically I am writing the sugar coating stuff. I have done that. Okay, let me write another program. Now I will not write decorator. I have just changed the name, but that changing the name doesn't really change the way it is supposed to be working. Okay, so it's a decorator. Inner function name is wrapper, and my original function name, well, of course, I can write some other name also. Divide I can write, and here I will write. So let me explain you what it is doing. See, what is the problem over here, or what is the requirement rather? I have I have a function, right? I have a function divide. It takes two parameter a b. It divides a by b. But try to understand this. What could happen here? In this particular function, when I am defining here, right? So when I invoke divide, I write 10 by 10 comma 2. I will get the result, right? 10 divided by 2. Fine, very nice. I write 5, I will get the result 2. Very nice. But by mistake, if I write 0, if I write 0, what is happening? I am getting error message. Now, what is the issue over here? See, this function has already been written. This is my original function. I know the problem, but I cannot modify this, right? If I don't modify, I can get this error. If I am invoking this divide and passing 0 to b, that is denominator, I'm going to get error. You cannot divide anything by 0. So that is a problem. So what I will do is just see, please concentrate over here. This is my function. I am not touching this. This function will be going as an argument here. Okay, so let me remove this. This is a little difficult to really digest. So let me write that I am invoking. Okay, let me only remove divide, not everything. Okay, so that is clear that this is the function. Now I will invoke decorator pass divide. Okay, so let us go to, I am passing divide, and this divide is internally known as func arg. You can write any name, right? Outer function with an argument. That argument is what? Argument is equal to func underscore arg. Inside, see what is happening. I've written wrapper. This wrapper is nothing but inner function, wrapping the function that needs to be modified. So what it will do? It will take a and b. Okay, it will take a and b. It is not getting invoked at this point in time. So if a is equal to 0, I will make a is equal to 1. So basically, if denominator happens to be 0, I am making denominator as 1, which means it is going to be neutral, right? Any number divided by 1 will be the same number. So if somebody is committing mistake while passing, if somebody is giving 0, then I will make it 1. And then I'm invoking this function. So what happens is that, see, b is coming as 0. I made b 1 and then I invoke this particular function. Where will I invoke this function? Just hang on. I am returning this inner function. I am not invoking here. So what happens? This is already defined. All these things are defined. I will, since decorator, see, this decorator is returning this wrapper. Wrapper is what? This is the function which is modifying my original function. I will have to store somewhere, right? Maybe I will write x again here. Now, I write like this. Nothing happens. Now just see. If I write like this, okay, write like this, what will happen now? When I am invoking x, my wrapper gets invoked, mind you, my wrapper gets invoked, and this is precisely where I have to give my input. See, decorator divide. Divide is going over here. Wrapper function needs a and numerator and denominator. I am doing this checking and then I would be invoking this. But all these things will happen outside, mind you. It is going to happen outside. See, if I am invoking wrapper over here, I will pass 10 comma 2 here, but I'm not doing here. No, I will do outside. So this wrapper goes here, gets copied with X. And whenever I am invoking wrapper, I have to pass two parameters. So what I'm doing, I'm passing 10 and 2. When I'm doing that, it is correcting and it will give me 5, right? So let us see what will be the result. 5. If I give 0, what will happen? 0 will get converted into 1 and I will get the output 10 divided by 1. I will get 10. But we do not write like this. We write by sugar coating it. By sugar coating, what I mean, or not sugar coating, syntactical sugar, I will apply syntactical sugar. So what I will do, just see here. I will write here, everything is fine. And I'm just going to write on top of this, I will write decorator. That's it. And now what I will do, remove this. This is ready, right? And then I will invoke divide by passing 10 and 2. Look, I am getting 5. So if I write 0, then I will get 10, correct? So what I have done, look, what I have done is my original function divide, which had some problem, I corrected using decorator without modifying my original function. This is what has done. And this is all about decorator. So what we will do is we will have more examples to solidify our understanding of decorator. For now, this is what it is. So all these notes are written. We have seen what are the building blocks to have a decorator in place, and we have written decorator and we invoke decorator in a lengthy way, and we also use syntactical sugar to invoke my decorator, right? That's all for now. Thank you for watching, and I will see you in the upcoming video.